The next section in chapter 3 that we're going to cover is determining the formula for a compound. So you guys have already seen this once in lab, so this should pretty much just be a refresher on how to calculate empirical formula. Okay, so the molecular formula is the regular formula for a chemical compound. It tells you how many atoms of each element are in the compound. So I have an example here, and we're going to write the molecular formula for it. Let me change my pen. Okay, so we have 2 carbon atoms, so C2, and we have 6 hydrogen atoms, so C2H6. This is the molecular formula. So if we write this as a ratio, so we have 2 carbons over 6 hydrogens. Now we can look at this just like a fraction. So the empirical formula is the reduced formula or the simplified formula. So if you were going to do this in a math class, you would reduce it by the least common multiple, or whichever number can be divided by into both. So we can divide both numbers by 2 and get 1 carbon for every 3 hydrogens. So remember, we divided the 2 by 2 and the 6 by 2. So this ratio gives us our empirical formula. So our empirical formula here, again, it's the simplest. So let me write this definition out. The simplest reduced ratio of atoms in a compound. Okay, so our empirical formula for this molecule is CH3. So we just have 1 carbon, so we don't need to write that. Now, if the ratio of atoms in the molecular formula cannot be reduced or simplified, the empirical formula is the same as the molecular formula. So there's a few examples of that. So let's look at a couple. So P3N5. We don't have anything that will go into both of those numbers other than 1. So the empirical formula here is the same as the molecular formula. C5H12 is another example. So again, we can't divide either one of these numbers by the same thing. So the empirical formula is going to be the same. So many different compounds can have the same empirical formula. So for example, if we have CH2 as the empirical formula, we could start with any of the following molecular formulas. So C2H4, there you could divide both of those by 2 to get CH2. C3H6, could divide both by 3 to get CH2. C4H8, you would divide both by 4 to get CH2. C5H10, divide both by 5 to get CH2. And C6H12, you could divide both by 6 to get CH2. So all of these compounds have the same empirical formula of CH2. So the way that we write that is CH2N, where N is an integer. So whenever you multiply the empirical formula by N, you get the molecular formula. So again, you guys will recognize this from lab. So now we're going to do an example. So we are given this question here to determine the empirical and molecular formulas for a compound that has the following mass percentages. 71.65% chlorine, 24.27% carbon, and 4.07% hydrogen. And the molar mass of the compound is known to be 98.96 grams per mole. Okay, so we were given the percentage for each element and the molar mass of the compound. So in this case, we know the mass of each element we need to know the mass of each element in 100 grams of compound, and we use 100 grams of compound because we're given percentages. So just like this statement here says, since mass percentage gives a number of grams for a particular element per 100 grams of compound, we base the calculation on 100 grams of the compound. Therefore, each percentage just represents the mass of grams of that element. So we would have 71.65 grams of chlorine, 24.27 grams of carbon, and 4.07 grams of hydrogen. Okay, so now we can use the atomic masses for each element to calculate how many moles of each element we have in our compound. So grams of chlorine to moles, our atomic mass of chlorine is 35.45 grams for every 1 mole. For carbon, our atomic mass is 12.01 grams for every 1 mole. And finally, for hydrogen, it's 1.008 grams for every 1 mole. Okay, so now we can do that math. And for chlorine, we get 2.021 moles of chlorine. For carbon, 2.021 moles of carbon. And for hydrogen, 4.04 moles of hydrogen. Okay, so now we need to divide each mole value by the smallest number of moles present. So in this case, we have the same number of moles for chlorine and the same number of moles for carbon, and they're both the smallest number, so we're going to use that 2.021 moles to divide all of the moles by. So we're starting with our moles. So moles of chlorine, we have 2.021 moles divided by 2.021 moles. That gives us 1. Moles carbon, 2.021 moles divided by 2.021 moles equals 1. So this is just giving our ratios of each element. And the last one, mole hydrogen, we calculated 4.04 moles, and we need to divide that by the smallest number, 2.021 moles. And that gives us approximately 2. Okay, so now we can take each of these numbers, and this is our ratio. So we have 1 chlorine, 1 carbon, to 2 hydrogens. So our empirical formula in that case then is Cl CH2. Okay, so now to determine our molecular formula, we need to take our we need to calculate the molar mass of the empirical formula. And you guys will recognize the formula that we're going to use from lab. Alright, so for chlorine, carbon, and hydrogen, we need to look at the molar masses. So we have, for chlorine, the molar mass is 35.45 grams per mole, and we just have one chlorine, so that's 35.45. For carbon, 12.01 grams per mole, and we just have one carbon. Then lastly, hydrogen is 1.008 grams per mole times 2 hydrogens equals 2.016 grams per mole. So if we do that math and round, we get an empirical formula mass of 49.48 grams per mole. Okay, so now if you'll remember our formula, so now we are going to calculate that integer n, which is equal to the molar mass that they gave us, so that's the molar mass of the molecular formula divided by the empirical formula mass. Okay, so our molar mass that they gave us in the problem was 98.96 grams per mole, and our empirical formula mass is what we calculated here, so 49.48 grams per mole, and we get an approximate value of 2. So this one is close enough to round up to 2. Remember, if it's something in between like 1.5 or 2.5, you would need to multiply by a number in order to get a whole number, like 2 or 3. So now our molecular formula remember, is equal to the empirical formula, so ClCH2 times the integer n, and our integer n we just calculated, ClCH2, 2, so our molecular formula is Cl2C2H4.